Okay, look at the very first question. The question is calculate the number of sigma and pi bond. Okay.
Okay.
So please turn off your mic and camera, everyone. And now you can see here, we have the very first question. We have to find out the number of sigma and pi bond. So this is cyanide one and this is aldehyde, okay? So if you look at the structure of aldehyde, it looks like this. So take your time and let me know how many sigma and pi bond in this compound. And this is the cyanide, which is also called nitrile. This is C triple bond N. So you can answer in chat group or even you can send me personal, you can inbox me, okay? So please tell me. Every dot is a carbon. This is bond line form. So look at this bonding pattern, carbon double bond carbon, carbon, C triple bond N, carbon and CHO. So carbon valency is 4. It means carbon can form maximum 4 bonds. So whenever single bond, it means 1 valency, double bond, 2 valency, triple bond, 3 valency. So look at this carbon, it has a double bond, which means 2 valency. To make this 4, we can add 2 more hydrogens. Similarly, if you look at this carbon, it already had 4, so no need to attach any hydrogen. This carbon has 2 bonds, so we can add 2 more hydrogens. And this one already have 4. And nitrogen can form 3 bonds, so this is clear in nitrogen. Okay. Now look at this carbon. It has 2 bonds, so we can add 2 more hydrogen to make this 4. And this carbon already has 4 valency. Now we can calculate number of sigma bond and pi bond. So pi bond is very clear. So let me know how many pi bond here. So you can see we have 1 pi here because double bond have 1 sigma and 1 pi and triple bond have 1 sigma and 2 pi. Okay. So overall, we have 2 pi here and 1 here. So 3 pi total. And number of sigma, how much? 1 sigma, 2 sigma, double bond have 1, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we have 14 sigma and 3 pi. Any doubt, please tell me with this question. Please tell me very quickly. Any doubt about the very first one? It's very simple. Okay, now move to the next question. Calculate the formal charge. The circled atom. Here we have to find out nitrogen and here this nitrogen, and this one. So let me tell you the trick to find out the formal charge. I said a video about the formal charge as well. First of all, we should know the valence electron of these atoms. So look at this periodic table BCNOF. So boron have 3 valence electron, carbon 4, nitrogen 5, oxygen 6, fluorine have 7. So suppose we have to find out here nitrogen. So look at the bonding. Now break all the sigma bond around nitrogen. So here 1 electron, here 1 electron, break this one, here 1 electron, here 1 electron, 1 electron, 1 electron, 1 electron and 1 electron. So the formula is valence electron minus total electron around that atom. So nitrogen valence electron is 5 minus how many electron around nitrogen? So look at 1, 2, 3, 4. So 5 minus 4 is plus 1. So this case nitrogen is plus 1. Make sense? Please tell me. You can say yes in chat box. Very good. Now look at this one. The B. What about the valence? Sorry, what about the formal charge on this nitrogen? The terminal nitrogen, this one. This nitrogen. I'm talking about this. So you can break the bond. 1, 2. Valence electron around nitrogen, valence electron nitrogen 5 minus. How many total electron on nitrogen? So 1, 2, 3, 4, 5, 6. 5 minus 6 is how much? Minus 1. So this nitrogen would be minus 1. Now look at the middle nitrogen. You can break this one as well. So 1, 2, 3, 4. So valence electron is 5 minus total electron around nitrogen 4. 5 minus 4 is plus 1. So middle one is plus 1. Now look at this terminal nitrogen. It looks like the same as the left. So 5 minus 1, 2, 3, 4, 5, 6 minus 1. So this one is a minus 1. Make sense? Very good. Okay, now the next question is, this is very simple. Identify the functional group. So, okay, I am going to ask this one. What is the name of this functional group? A. I'm not going to give you options. So please tell me. What it should be. Okay, someone is saying ester, ketone, acid. Wait, look at this, RCOOR. This is called ester. RCOOH. This one is known as carboxylic. RCONH2, known as amide. RCOR, this is called ketone. And RCOH, this is called aldehyde. This is called aldehyde. So if you look at this circle, this one is a carbon. So carbon, now double bond O. Right hand side, we have another oxygen, oxygen. Now we have a carbon chain and we can represent carbon chain through R. And the left part is also carbon chains, which means R. So RCOR is ester. So A is ester. So now you have to compare this B. Now let me know what should be B. Yes, because this is a carbon, double bond O. Right side we have again a carbon chain and we can represent carbon chain as R. Left side we have a carbon chain, we can represent through R. So RCOR, which is called ketone. What about this one? C. Yes, very good. So you can say this is C double bond O, having right side N, and again a carbon chain, and left side again a carbon chain. So this is amide.
Yeah.
Please turn off your mic, please. My request to everyone. Okay, what about this one? This D. Yeah, this is amine. This is amine. Because nitrogen is bonded through carbon. Okay, now let me know what is the nature of this amine. Is it primary, secondary, or tertiary? What kind of amine is this? When nitrogen is bonded directly, look at here. When nitrogen is bonded directly with one carbon, that's called primary. When nitrogen is bonded with two carbons, secondary. And when nitrogen is directly bonded with three carbon, which is called tertiary. So here nitrogen is bonded directly with two carbons. So this is a secondary amine. Secondary amine. Make sense? Okay. Now the next question. Figure out the total number of hydrogen in the given compound. So we have a carbon skeleton and you have to find out the total number of hydrogen. And one more thing I would like to tell you, nitrogen can form three bonds. Nitrogen can form three bonds. Okay, so it is very clear carbon have four valency. So look at this carbon, 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 carbon. This one also carbon, this one also carbon, this one carbon, 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 and this one carbon. Now look at here. This carbon have three, valency. You can see one on the double bond and left one is a single bond. And it should be four. So we can add one more H here. This carbon also have three valencies, so one more hydrogen to make it four. This one have three valencies, so one more hydrogen. This one have three, so one more. This one have three, one more. This one already have four, so no need to attach any hydrogen. This carbon also have four. This carbon have two bonds, so we can add two more H. Now I said that nitrogen can form three bond. So this one have a double bond, so we can add one more H. This carbon have three bonds, so one hydrogen. This one already have four valency. This one have two bonds, so we can add two more hydrogens. And this nitrogen already have three bonds, so no need to attach any hydrogen. And this carbon have three valency, so one more H. So total hydrogen how much? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so we have 12 proton, 12 hydrogen. Any doubt? Please tell me, everyone. It makes sense? Perfect. Okay, now the next question is identify the hybridization state of atom in the given compound. So I would like to tell you a trick. Simple hydrocarbon, in case of simple hydrocarbon. Hydrocarbon means carbon and hydrogen containing compound. Simple means it could be a single bond, double bond, and triple bond. So whenever we have 0 pi, whenever pi bond is 0, it would be sp3. Whenever we have 1 pi bond, it would be sp2. And whenever we have 2 pi, that would be sp. So look at this carbon. This carbon have 1 pi bond, so it should be sp2. Make sense? What about this carbon? I'm talking about this. sp2, okay? Because again, we have 1 pi bond. And what about this carbon, this carbon? sp2 again, because again 1 pi bond. I told you double bond always have 1 pi, triple have 2 pi, single bond have 0 pi. So now look at this carbon. It has a triple bond, which means 2 pi, so it would be sp, and this one also sp. Make sense? What about oxygen? I told you this rule, the pi bond is only valid for simple hydrocarbon. Oxygen is not a hydrocarbon. So whenever you have such a kind of atom, then find out the electron pair. Electron pair. And here hybridization. Electron pair means number of sigma plus lone pair. Number of sigma plus lone pair. Or negative charge. So whenever the total number of electron pair is 5, then it would be sp3d. When 4, it would be sp3. 3 sp2, and whenever 2, that would be sp. So look at this oxygen. How many sigma bond around oxygen? Just 1 sigma. How many lone pair around oxygen? 2 lone pair. So total electron pair is how much? 3. So 3 means sp2. Make sense? Okay. What about this nitrogen? Yes, we have 1 lone pair plus 2 sigma. So total 3 electron pair. So 3 means sp2. So this nitrogen would be sp2. Make sense? Now look at this carbon. This is simple hydrocarbon, so it has 1 pi sp2. Simple hydrocarbon 1 pi sp2. 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 And this one also sp2. Make sense? Okay. Okay, may I give you another question, please? And you can take your time and tell me the answer, okay? What is the hybridization state of this oxygen? This oxygen, this carbon, and this nitrogen. I'm going to mark as A, B, C, D. Okay, let me know the very first one, A. And one more thing, you should know how many lone pair on any atom. You should know. So nitrogen can form 3 bond and 1 lone pair. They have 1 lone pair and 3 bond. So there should be a lone pair. Oxygen can have 2 bond and 2 lone pair. This one for nitrogen, this one for oxygen. Okay, so nitrogen is what? Tell me everyone. Yes, sp. Very good job. Why? Because nitrogen have 1 sigma plus 1 lone pair, total 2 electron pair. So 2 electron pair means sp. What about the carbon? Yes, carbon again. I told you, whenever 2 pi bond, that means sp. So triple bond have 2 pi, so it would be sp. What about this oxygen? Okay, let me know how many lone pair are on this oxygen. What number of lone pair? Yes, because oxygen can form 2 bond, which means 2 lone pair. So we can say oxygen have 2 lone pair and 1 sigma, so total 3 electron pair. So 3 means sp2. What about this oxygen? Yes, 2 lone pair, 2 sigma, total 4 electron pair. So 4 electron pair means sp3. Make sense? Okay, I'm going to add another question here. What is the formal charge of this oxygen? Formal charge oxygen. I told you the valence electron, boron, carbon, nitrogen, oxygen, fluorine. It should be 3, 4, 5, 6, 7. What is the formal charge of this oxygen? I told you the trick. Number of valence electron minus number of electron around that atom. So the valence electron of oxygen is how much? 6 minus. Now break this bond. I told you break this bond. So this should be 1 electron, this should be 1 electron. So total how many electron? 2 to 4 to 6. So 6 minus 6 is 0. Make sense? Okay, what about the formal charge of this nitrogen? Last question of this problem. Formal charge of nitrogen. Formula is how what? Formal charge, valence electron minus number of total electron. So nitrogen valence electron is 5. Total electron, you can break this bond. So 1, 1, another 1. So how many? 3 to 5. 5 minus 5 would be 0. So it should be 0. Make sense? It makes sense to everyone. My request to those candidates who joined me just now, so please watch the recording after the class because we have done already the problem based on the formal charge, okay? So take your time. Now move to the question number 6. Identify localized and delocalized lone pairs in given structure. I have already recorded a video on resonance, localized and delocalized lone pairs. So if you have watched those videos, then you can answer this question. So delocalized means conjugated or resonance. Localized means no resonance. No resonance. Okay, so first of all, let me know about this nitrogen. What is the nature of this lone pair? Localized or delocalized? You can answer if it is delocalized, write down the D only. And if it is localized, you can say L only. So D and L. Okay, do you want me to explain this? Please tell me, do you want me to explain how to identify the resonance? Okay. Okay. Give me 1 second. Now look at this. There is a term called conjugate species. Conjugate species. And these species like negative charge, lone pair, radical, double bond, positive charge, and vacant orbital as well. Vacant orbital case is very rare, but it is under this condition. So I can write down here vacant orbital, the last case. This is called negative charge. This one is a lone pair. This one is a radical. This one is a double bond. This one is a positive charge. And this one is a vacant orbital. So the condition is when conjugate species is separated by single bond. When conjugate species is separated by single bond, that is a condition of resonance. And these species is known as delocalized. Delocalized. For example, So lone pair is a conjugate species, double bond is a conjugate species, and you can see it is separated by a single bond. So it means both are conjugated because we have the condition for this. So this is conjugated. So we can say this is delocalized and this double bond is also delocalized. So this lone pair is delocalized. Make sense? Okay, another one, suppose this one. So now you can see this lone pair, which is called conjugate species. This one is also conjugate species, but we don't have a single bond between them. We have more than one single bond. So both are not in resonance, no conjugation. It means this is localized and this one is also localized. Make sense? When any atom have more than one lone pair, the conjugated I am talking about, the conjugated lone pair means resonance one means delocalized. I said when any atom have more than one lone pair, then only one will be conjugated. For example, look at this oxygen. Lone pair is a conjugate species. Double bond is a conjugate species. Both are separated by a single bond. So this is in resonance. Am I right? Please tell me. It makes sense. But this oxygen have two lone pair. This oxygen have two lone pair. So only one would be delocalized. Any one it can be. So if this is delocalized, then it would be localized. Make sense? For example, look at this group. This is again the condition of resonance. Lone pair and double bond both are conjugate species separated by a single bond. So it means we have a condition of resonance. An oxygen have more than one lone pair, so only one would be delocalized. So this lone pair would be localized. Make sense? The last point of this, when any atom have lone pair and double bond both, then double bond will take part in resonance. For example, look at this compound. This double bond is a conjugate species. This double bond is a conjugate species. Both are separated by a single bond. It means they both are in resonance. Now look at the nitrogen. If you are going to consider the double bond or any of the lone pair, double bond or this is also conjugated. You can see if double bond, then we have a single bond here. And if the lone pair, we have a single bond. So both are in resonance, but the priority is given to the double bond. So if double bond is conjugated here, then lone pair would be non-conjugated and also known as localized. And this double bond is called delocalized. Make sense? So simple thing is that whenever any atom have lone pair and double bond and it is a part of conjugation or resonance, then double bond has more priority over the lone pair. So double bond would be conjugated and lone pair would be non-conjugated or localized. It makes sense? Please tell me everyone, it makes sense? Look at this case. This lone pair and double bond, between them we have a single bond. It means delocalized, delocalized. But what about nitrogen? Which one would be delocalized here? Lone pair or double bond? Tell me. Yes, double bond would be my delocalized and lone pair would be localized. Make sense? My request to everyone, say yes or no. Okay, perfect. So now we have this question. So what about this nitrogen's lone pair? Delocalized or localized? Good job. This is delocalized. Localized means no resonance. Localized, it means it is not going to move. Okay, but in resonance, electron moves. That's why delocalized the term is. Okay, what about this nitrogen? Delocalized or localized? Listen, this is not the case of resonance, so this is localized. Okay, what about this? Oxygen's double bond is going to take part in resonance, so lone pair would be localized. Because I told you, whenever any atom has lone pair and double bond, then double bond would be conjugated. You can see the double bond and lone pair, between them we have a single bond. Make sense? What about this nitrogen, the ring nitrogen, the lone pair, localized or delocalized? Yes, it would be localized. It makes sense. Okay. So now the next is resonance drawing. I'm going to tell you, can you explain the second one again? So the second one is localized. Which one you are talking about, the second one? This is my supposed to be X, this is Y, this is Z, this is supposed to be P. Which one? The oxygen one? Okay, you can break down the component like this. Suppose we have CS3, C double bond O, and H2. Now look at the lone pair of the nitrogen and this oxygen double bond. So oxygen have a lone pair and double bond both, and you can see between them we have a single bond. So you can say this is my delocalized. So you can say this one also delocalized, but I told you whenever lone pair and double bond would be delocalized and both the lone pair would be localized. Make sense? So double bond has more priority over the lone pair. Okay, now we have the next question, draw the resonance structure. I discussed a lot how to draw the resonance structure. So I'm not going to explain from the very basic. I'm just going to tell you. You can see this lone pair, next to this lone pair, we have a positive charge. And in the right hand side, the nitrogen have a lone pair. I told you whenever any species has lone pair, suppose nitrogen is going to donate its lone pair like that. So the arrow is very important. Whenever arrow on the bond, it means single will become double. So in resonance structure, basic connectivity is not going to change. So you can see this bond have electrons, so it would become double. Nitrogen donates its lone pair of electrons, so nitrogen would be electron deficient, and that has a positive charge because it donated its lone pair of electron. The CO would remain same. This oxygen have a lone pair and H. So this is the condition when nitrogen is going to donate. Clear? Now the second condition, when oxygen is going to donate like this. So same concept. Oxygen donates its lone pair of electron to the neighboring bond. So we have a double bond here because bonded electron, the arrow on the bond. and oxygen donate its lone pair, so positive charge. We have two lone pair of electron, but it donates only one lone pair, so we still have a one lone pair. So these two are the possible resonance structure. Make sense? Clear? Okay, and please watch the video as well. My request to everyone, watch the video of resonance structure, resonance hybrid, comparison of stability of resonance structure. Okay, now look at the C. The positive charge next to the double bond here we have. So positive is electron deficient. So it grabs the double bonded electron like that. Okay. So as a result of it, look at this bond have arrow, this bond. So it becomes double. This nitrogen has tail of arrow. It starts from the middle of the bond, but it is located on this carbon. So it would be positively charged. And the rest of the lone pair would remain same like that. This is the first resonance structure. Now second. Now this positive charge is in resonance with this pi bond, and now it will shift like that. So as a result of it, you can see this single bond would become double. This carbon have tail of arrow, so positive, and this double bond would remain same. And in the next structure, this double bond is going to shift here. So this single would become double, and this nitrogen have positive charge. Make sense? This atom is not in resonance. That's why there is no movement of charge on this atom. You can see there is no charge over here. It makes sense? Okay. Now look at the B. Again, we can say here, this pi bond is close to the positive charge, so we can shift over here. So as a result of it, this bond have arrows, so it should be a double bond, and this carbon have tail, so positive. Now again, very simple. Lone pair, the neighbor is positive, so it can donate its electron. So this bond have arrow, so double. Oxygen donates its lone pair, so positive, and two lone pairs, so one lone pair would remain same. It makes sense? Please tell me, everyone. Perfect. Now the next question is, arrange in decreasing order of stability of the given resonance structure. If you have watched my video, I told you 4 rules to compare the stability of resonance structure. What is rule 1? Tell me, everyone. What was the rule 1 if you have watched my videos? Yes, maximum number of double bond. So whenever you have maximum number of double bond, then that would be the most stable resonance structure. And you have to follow each rules one by one. Each rule one by one. So first rule is maximum number of double bond. Second rule, tell me, second rule. Yes, neutral would be more stable than charged. So neutral compound would be more stable than charge. Third rule, tell me third rule. Negative charge on more electronegative element. Negative charge on more electronegative element would be more stable. And what was the fourth rule? Opposite charges closer. Opposite charges closer would be more stable. Make sense? And you have to apply each rule one by one. So if we are going to apply rule one, maximum number of double bond, so we can say this one have maximum number of double bond, this one have double bond, this one also have double bond. Now the next, neutral. So first one is neutral. So first would be the most. Now between second and third, I told you they have equal number of double bond. They both are charged containing compound. Now third, negative charge on more electronegative element. Here oxygen is negatively charged. Here oxygen is negatively charged. Here oxygen is positively charged. So positive charge on oxygen is highly unstable. Highly unstable. Okay. So this, the third would be the most stable. First, third, then second, and the last would be fourth. Any doubt? Please tell me, everyone. Any doubt about this? Follow each rule one by one, okay? So first would be the most because neutral and maximum number of double bond. The fourth would be the least because no double bond. Between second and third, this oxygen is definitely common. But look at this oxygen. This oxygen have a positive charge. So negative charge on more electronegative would be a stable thing. But if you are going to keep positive charge on more electronegative, positive charge on more electronegative would be highly unstable. Okay, that's why the second would be the less stable. Yes, whenever you don't have a double bond, that would be the least. Okay, this is very beautiful question. Which lone pair will protonate? In the next, once you are going to learn reaction mechanism, you can see there is a step, or in Orgo 1 and Orgo 2, the step is protonation step. Okay. So the simple thing is that lone pair can donate its electron, but we have two atoms in which we have a lone pair. So which lone pair is going to protonate? So the simple thing is that draw the resonance structure. So base can protonate. The concept is base can protonate. So draw the resonance structure. So this nitrogen can donate its electron and this CO would break like that because CO is a polar bond and it always break like that. Okay. So draw the resonance structure. This bond have arrow. So double nitrogen donate its lone pair. So positive, and this double bond break into single bond. Oxygen have head of arrow. So negative charge. Make sense? Tell me. So this oxygen is negatively charged. It would act as a base. So it would grab this proton. So simply we can say this lone pair is going to protonate because that is not in resonance. So the final step would be this. Clear? This is the protonation step. It makes sense? The arrow should start from the lone pair of the oxygen to the proton. Clear? So the lone pair with no resonance is the one. Yes, of course. Why? Because base means ability to donate its lone pair. Availability to donate its lone pair. To donate its lone pair to a proton. So if my lone pair is busy in resonance, then how can I donate my lone pair to a proton? It means my lone pair should be non-conjugated. If the lone pair is non-conjugated, it means it can donate to a proton. Make sense? Perfect. Now the next chapter is acid and base. Okay, so draw the mechanism of the proton transfer, curved arrow. So look at the simple thing. In this is the product, this is the reactant. So you can see here, this is water becomes OH minus. It means H2O donate its proton. So proton donor is what? Acid. So this is acid. CH3O becomes CH3OH. It means proton acceptor. So proton acceptor is my base. It makes sense? Please tell me, everyone. Now look at the arrow pushing. So finally, it is very clear. This CH3O minus is my base, water is my acid, and you know that base grabs a proton. So it means arrow should start from the lone pair of the oxygen to the acid's proton, this. And this oxygen hydrogen bond is going to break like that. And recently I told you, head of arrow indicates negative charge, tail indicates positive charge. So you can see oxygen have the head, that's why oxygen is negative. And this CH3O, O grabs this proton and there is a bond. Bond means, this arrow means bond. So CH3O is going to take this proton. So there is a bond between them. That's why this is the bond. It makes sense? Okay. Now we have to define the Bronsted acid, Bronsted base, conjugate acid, conjugate base in the given reaction. So Bronsted acid is what? Proton donor. Bronsted base, proton acceptor. Conjugate acid is formed by addition of proton, and conjugate base is formed removal of proton. So now look at here, this water is a proton donor, so Bronsted acid. CH3O grabs the proton, so proton acceptor, so Bronsted base, CH3O minus. And now look at here, conjugate acid and conjugate base. So look at the H2O. H2O donates its proton, means H2O loses its proton. So I said that removal of proton forms conjugate base. So once you remove a proton from H2O, it forms OH. So loss of a proton, if you compare H2O with OH. So loss of proton is conjugate base. And CH3O have extra proton here. So this is proton addition. So this is conjugate acid. Make sense? Please tell me, everyone. Perfect. Write down the conjugate acid and conjugate base. So what is the conjugate acid of ammonia? Tell me, everyone. Conjugate acid is formed by addition of proton addition. So NH3 have a lone pair. If you add a proton, what it should be? We have extra proton, NH4. What about the charges? Is it neutral, positive, or negative? So you can see this is neutral, but this is positive. So extra, we have a positive here because hydrogen has proton, which is a positively charged. So we can show here positive charge. So conjugate acid would be NH4 plus. What is conjugate base? Loss of proton. So once you remove the proton from NH3, it would be NH2. And this is a neutral. So you have to keep a charge which is called negative because we are removing H plus. Okay. So it would be NH2 minus. Make sense? Okay, what is the conjugate acid of H2SO4? Tell me, everyone. HSO4 minus conjugate acid. It means addition of proton. So proton addition. So we have extra proton. So H2SO4. And this is neutral. Why? Because this is negative. This is positive. Cancel out. So product would be neutral. And what is conjugate base? You know that in conjugate base, we have a negative charge. So it would be SO4. We still have negative and there is another negative. So -2. Very good job. Okay, now we have a question. Complete the above reaction. And you can represent the curved arrow. So you have my Facebook account. You can share your arrow and send me message. I am waiting for everyone. Please do it fast. Show me the arrow. Base would grab a proton. The concept is. So arrow should start from base to acid. This is the curved arrow. It starts, the tail should be base, head should be towards acid proton. So simple thing is that if we have a base and we have a proton bonded to the acid, so base grabs this proton and this hydrogen and atom bond is going to break like that. Please send me. I got one answer and it's absolutely perfect. Good job, guys. Well done. I got another answer and it's correct. I'm waiting for a few more. So well done, Karina. Well done, Jesus. I'm waiting for a few more. So this is a base, and I said that arrow should start from the base to a proton like that. And this hydrogen oxygen bond is going to break like that. Clear? And I told you, so now this bond is going to break. So you have a benzene ring and oxygen. Now oxygen have a head of arrow, and head of arrow means negative. So this oxygen is negatively charged. And this base OH is going to grab a proton, so it would become H2O. Clear? So this is my Bronsted acid. This is my Bronsted base. This is formed by the loss of protons, so conjugate base, and it is formed by the addition of protons, so conjugate acid. It makes sense? Okay, next is we have to identify the Lewis acid and Lewis base. So what is the definition of Lewis acid? Tell me. What is the definition of Lewis acid? Electron pair acceptor or donor? Acceptor or donor? Okay, if you have a confusion, let me tell you a trick. So look at here. Lewis acid, and whenever Lewis concept, that is always related to electron. So acid alphabet alphabet A means acceptor, so we can say electron acceptor. Make sense? If acid is electron acceptor, then base would be donor. Simple. So nitrogen's lone pair, and this is a proton. And you can see this is NH4 plus. It means there is an extra proton in ammonia. So ammonia have extra proton. It means ammonia grabs this proton. Make sense? So arrow should be like that. So lone pair donor is my ammonia, which is acting here Lewis base. And H plus grabs the lone pair of electrons. So this is a Lewis acid. It makes sense? Okay, now the next second case. Aluminium have a vacant orbital as well. Aluminium, iron, So lone pair is going to donate the electron to its vacant orbital. So this is electron pair donor. So it would be Lewis base. And this is acceptor, so Lewis acid. Generally, Lewis base are electron pair donor, and it could be a lone pair or negative charge. Okay. So whenever you have a lone pair and negative charge, it means it is generally Lewis base because it can donate its electron. Now the next is arrange in decreasing order of acidic strength. So whenever you have to compare the acidic strength, the very first thing is remove the proton bonded to these kind of atom: fluorine, oxygen, nitrogen, triple bonded carbon and sulfur. First job is always to deprotonate. You have to remove this proton. So once you remove this proton, it would be negative, it would be negative, it would be negative, it would be negative. Make sense? Please tell me, everyone. So first job is to draw the conjugate base. Conjugate base means removal of proton. So now once you remove the proton, then apply cardio. C stands for charge. You can see every atom is negatively charged, so charge is not the deciding factor. Make sense? Please say yes. Okay, next is atom. So we have a different kind of atom. We have oxygen, we have sulfur, we have carbon, and we have nitrogen. Carbon, nitrogen. We have different kind of atom. So whenever you have a different kind of atom, then you have two concepts: electronegativity and size. When groups belongs to same period, generally this is my period B, C, N, O, F. Okay, this is the period. So here you can see the electronegativity. It means left to right electronegativity increases, acidic strength increases. Now in the size, once you are moving down the group fluorine, chlorine, bromine, iodine, this is the same group, and you can move down the group, size increases, acidic strength increases. Now I'm going to locate the positions of oxygen, sulfur, nitrogen, and carbon. So look at the positioning here. We have a space here. B, C, N, O, F. Below oxygen, we have a sulfur, here phosphorus, here silicon, here aluminium. So now we have the elements. We have negative over oxygen, we have a negative over sulfur, we have a negative over carbon, and we have a negative over nitrogen, I think as well. Yes, nitrogen. Now you know that if you move left to right, oxygen is right. Makes sense? And oxygen and sulfur belongs to same group. So down the group, size increases. Size increases means acidic strength increases. So sulfur has highest acidic strength. So which one is sulfur? The C. So C would be the most. Now, sulfur and oxygen. So oxygen is this one. So this is A. Now carbon and nitrogen. So carbon, nitrogen belongs to same period. So electronegativity. So B and then D. It makes sense. Please tell me, everyone. My request to everyone, it makes sense. Now we have very last question in this class, the concept of aromatic and anti-aromatic and non-aromatic. So let's start this one. So if you want to check aromatic, so we have few conditions: cyclic, cyclic conjugated, planar, and follow this conjugated pi electron. Whenever number is 2, 6, 10, and 14, it would be aromatic. And I told you, whenever you have a lone pair, whenever you have a negative charge, whenever we have a double bond, okay, it can give you 2 pi electron. And we have to find only the conjugated, which means delocalized pi electron for aromatic. So look at the first case. It is cyclic. You can see it is cyclic conjugated. It means entire ring have resonance. You can check lone pair, single, double, single, double, single, and again lone pair. So this is cyclic conjugated. Whenever system is cyclic conjugated, 99% it would be planar. And now the conjugated pi electron, how much we have? This is delocalized, this is delocalized, this lone pair is also delocalized. So 2, 2, 2. So we have 6 conjugated or delocalized pi electron. And I told you whenever the number is 2, 6, 10, and 14, it would be aromatic. So this is aromatic. Makes sense, the very first case? Perfect. Now look at the second case. Cyclic, cyclic conjugated, planar. How many delocalized pi electron? Tell me, everyone. Yes, 6, 2, 2. And whenever we have more than one lone pair, only one delocalized and next one is localized. So it can give 2. So total 6 pi electrons, 6 would be aromatic. What about the third one? Cyclic, cyclic conjugated, yes or no? Whenever I am saying cyclic conjugated, it means every atom in the ring must be in conjugation, must be in resonance, every atom in the ring. Do you think it has a fully conjugated system? No, because this atom is not in conjugation. Make sense? So whenever system is not fully conjugated, it means non-planar. So planar means sp2 hybridized. Planar means sp2. And this carbon is sp3. So non-planar means non-aromatic. Make sense? Okay, fourth case is very, very important. If you are going to see here cyclic, yes, cyclic conjugated, yes, planar. Look at here. If you look at the pi electron 2, 4, 6, 8, and 10. According to the rule, it has 10 pi electron and it looks like aromatic, but it is non-aromatic due to this internal hydrogen repulsion. This is exceptional case in the book. Whenever hydrogen repel to each other, it loses its planarity. Okay. So due to strain, this compound is a non-planar and that's why it is a non-aromatic. So this is very, very important case. Make sense? Now the next case, fifth, cyclic, cyclic conjugated, planar. How many conjugated pi electron? 2 to 4 to 6. So 6 pi electron means aromatic. Now look at this one. This is very good question, nitrogen one. This is cyclic. This is cyclic conjugated. Okay, now let me know what is the hybridization of this nitrogen. Tell me everyone. Are you sure this is sp2? This is sp3. Why? Because 1 sigma, another 1 sigma, and another 1 sigma, 4 sigma. So 4 sigma means 4 electron pair. That means sp3. So which is not possible. This is non-planar. So non-planar means non-aromatic. Make sense? Perfect. Okay, the third, this one, number 8, CO bond is a polar bond. So we can break the CO bond, means we can draw the resonance structure of this. Oxygen negative, carbon would be positive, and this is double bond. So if you want to check aromaticity, then you should first look at the cyclic. So this is cyclic. Yes, this is cyclic. So we have to apply the aromaticity in the cyclic compound. So this is cyclic. Cyclic conjugated, yes. Planar, yes. How many conjugated pi electron? Only 2, because positive has 0 pi. So 2 pi electron means aromatic. So if this is aromatic, this one also aromatic, because both are resonance structure of each other. Okay, this one is cyclic, cyclic conjugated, planar. How many conjugated pi electron? Delocalized, 2, 2, negative also 2, 6. So 6 means aromatic. Make sense? Okay, number 9. We can apply aromaticity in the ring system only, and it is very clear benzene is aromatic. So this compound would be aromatic because this is cyclic, cyclic conjugated, planar, 6 pi electrons. So it would be aromatic. This one, let me know the 10th one. This is cyclic. Is it cyclic conjugated? Do you think every atom in the ring have resonance? Fully conjugated system? No, this atom is not in resonance. So non-aromatic. Okay, next 11th. Cyclic, yes. Cyclic conjugated, yes. Planar, yes. How many conjugated? How many delocalized pi electron? Yes, 2 to 4 to 6 to 8. Whenever delocalized or conjugated pi electron is 4, 8, 12, 16, it would be anti-aromatic. Whenever the number is 2, 6, 10, 14, it would be aromatic. This is the delocalized electron. Make sense? Please tell me, everyone. Perfect. So this is all about the chapter 1 and 2. And I have covered, I think, most of the important topics related to these two chapters. It makes sense? And I'm not charging anything for this webinar. So my request to each and every student, please share my work to your friends, and please share your thoughts about this class. And do you know what I'm trying to say? If you can post something about my tutoring in that group, it would help me a lot. Okay. So this is the only thing which I want from you guys. And believe me, I will break down the complex topics, reactions, in a very simplified way. So no need to memorize anything. You have to work on the basics only. Do you have any question? And please watch my videos related to these two chapters. This is my request to everyone. Okay, it would help you a lot. And then you can watch this recording as well. I will share the recording. Make sense? Perfect. Thank you so much, everyone. Good day. Bye-bye.